One of those things that happens at companies is someone asks you for an initial idea for something, and that initial idea ends up being impossible. And when you tell them that you've changed what the presentation is going to be, the original idea is what goes out into all of the material. So apologies, you've been rugged. You're in Web3, you're used to it. I'm not going to show you how to use Privy to get automatically sponsored gas because that's not possible yet, although I met with them yesterday and they're very interested in working with us to figure that out, so hopefully we'll be doing that soon. What I'm going to do today is I'm going to walk everyone through our brand new tutorial for a brand new feature in FCL, which is our front-end library, that lets you seamlessly integrate with a Wagmi VM RainbowKit stack on EVM and connect to the Cadence network at the same time, which unlocks a lot of cool things. One of those, which I'm going to show now, is the ability to call an arbitrary number of transactions on Flow EVM with just one signature. So if anyone wants, you can follow along and do this coding along. If not, you can just listen, that's fine too. But if you go to developers.flow.com and click on our new tutorial section, we're filling that out with some more advanced and complicated tutorials that don't really fit neatly on the Cadence side or the EVM side. And it's under there under Cross-EVM app, and this is the introduction to it. So it's the first in this series of all of the cool things that you can do. And then the other thing that we're going to do today is something that I have not done yet, and I have no idea what's going to happen, is I made this in a rush. I was sick last week, and so didn't have quite the time we hoped to get this ready. So I've only tried this with 10 transactions, so I don't know what happens or what the limit is. So we're going to show how to do it with 10 transactions, and then we're going to double it. And then we're going to double it again and double it again until it breaks and see what happens. So I don't know, maybe we'll set some records for transaction throughput and flow, at least on the test net. Maybe we'll break the test net, knocking on wood, hopefully not, but we'll find out. Okay, so if you want to follow along and if you want to do this, the beginning of the tutorial gives an introduction, which I've just done. Our objectives are we're going to build an app that seamlessly integrates Flow Cadence and Flow EVM connections, add Cadence features to a RainbowKit Wagmi VM app, and use the Flow client library and some scaffolding that we'll provide to enable a multi-call contract writes to Flow EVM, or batch transactions is probably a better way to say that. This is not about front-end development. We're going to provide things for that. We're going to skip over and hand wave some React development, some components that are all provided. And we assume that you have some familiarity with building smart contracts and building front ends for smart contracts. So the first thing that you want to do is under getting started is click the link for the FCL plus RainbowKit plus Wagmi integration demo that's been built by the team. And we're going to fork this. Which actually, I'm not going to fork it because I've already forked it. So I'm just going to make a copy because I don't need to save this. I don't need to push anything to this. But you'll want to fork it because you want to be able to make your changes and use the scaffold as a start for an app. So I'm going to cd into source, git clone this, and I'll call it Cross-VM. That is not on the screen. That's fascinating. So I've got my terminal up. I'm not sure why you can't see it, but I'm just cloning the repo. I trust that all of you know how to do that. Thank you for letting me know, though. If anything else doesn't show up that you can't see, let me know. That's interesting. I guess there's some built-in feature that it doesn't show the console. And it didn't download. Of course, live demos are always perilous. Let's try this again. And the monitor is gone. Let me try sharing again. Maybe that's what happened. Maybe the screen mirroring crashed. We can see it in a very tiny view again. Does anyone know how to fix this?
I think you just would click it like a select. There's like a blue select on it.
Samsung TV Plus, Disney. Maybe. Oh, you can see my. So the connection must have just failed because you can see my terminal now. Did the battery die on this thing? No, it's working. Oh, there we go. I found the no, that's some kind of multi-screen thing.
But then maybe you could see.
Yeah. Maybe. Maybe I'm just too close. Don't. I can't feel any there. No. Let's see here. Here we go. Multi-view. Connect a device. It's selected here. There we go. Almost full screen.
Yeah.
There we go. Thank you for coming to my demonstration. This is how you do screen mirroring between an Apple and a Samsung TV. Technology from different backgrounds can get along. We can all learn from this. Okay. And we lost our internet with that. Did we get the clone?
Yeah.
The internet's been down for a while?
Yeah, an hour.
With the Castlemarne private guest internet?
Yeah.
That's been down for a while. Okie dokie. Now we've got an interesting problem because this requires the internet to work.
Do you have, maybe you can, are you off personal hotspot yourself?
I have a personal hotspot, but I'm connected to the TV through the Wi-Fi.
Oh,
Yeah, so let's see, let's confirm that it is through the Wi-Fi. So let's try disconnecting. And yeah, no, you can't see that I'm changing focus now.
Yeah.
Okie dokie.
I think it's a good thing. I have it on my phone. I'm connected.
Oh, you think the internet is working again?
I think it's working.
Okay, let's try reconnecting.
You got it working? Yeah.
Let's try screen mirroring again. It says we are screen mirroring. Let's turn it off, turn it on. Play with a fidget spinner while it spins. Spinning, spinning, spinning. Could not connect. And people look at me like I'm a dinosaur when I like things that have cables and you plug them in and they just work. Okay, that looks promising. Oh, we're at the blue rectangle. We know how to do this one. Haha, okay. All right, now let's hope the internet works and we can clone this. It cloned, awesome. Okay, we are in business. So going through this, the first thing we're gonna do is we're gonna open up the app that we've just cloned, the scaffold, and run it locally and walk through it. So let's ignore the errors that I keep ignoring and not fixing in VS Code. And we'll do npm install, give that a moment to go through. How does that look in terms of screen size? That's not so bad, is it? Okay. All right, we'll use npm run dev and check out localhost 3000. Uh-oh, there we go. Okay, so we've got an app. I've connected to it with the Flow wallet. And we can see that. And we've got a button here that says send batch transaction example. Now it's going to error because it's confused about the state. So let's disconnect and reconnect. Do a better job of typing in front of an audience. One more time. Okay, so we've got a transaction. We're approving it. It's on testnet, but on mainnet too with Flow wallet. It would be the Flow wallet is covering this gas for you. So we'll run it and we'll wait a minute and we get 2 transaction hashes. And if we copy one of these and check it out in EVM testnet.flowscan.io, you can see here is one testnet EVM transaction doing something with some wrapped flow. And go grab the other one, search for it. And here, if you dig into this, you'll see that this is a second transaction where we have called the approve function on an ERC20 contract. So demonstrating minting or wrapping some tokens and granting an approval to a specific address to do something with those tokens with one signature, which is neat. But of course, that's not what we want. We want to do our stuff with our own contracts and our own transactions. So linked in the tutorial. Well, real quick, let's go over what's happening here. So Flow EVM works in 2 ways depending on the wallet that is calling the transaction. If you're using a regular EOA, so you can log into it with your MetaMask or your Coinbase wallet or whatever you're using, then it works more or less the same as you're used to. The transactions go through the same process, they get processed. But the Flow wallet works a little differently. When you're using the Flow wallet, it creates for you, which is called a COA or cadence-owned account, which takes advantage of Flow's native account abstraction. And it essentially uses the Cadence wallet and a Cadence transaction to wrap the EVM transaction and uses its own permissions over your EVM wallet to do the transaction. And since it has its own permissions, that means if you sign a Cadence transaction, your Cadence wallet is allowed to sign anything that the transaction allows it to in an EVM transaction. So what we're actually doing here, if you're not familiar with Cadence, is we're borrowing that reference, that authority to the Cadence-owned account, and then we're just looping through a list of EVM transactions that have been provided to it, and we're executing them. And it even has a neat feature here that I want to call out, although we're not going to do it in the tutorial, that you can mark these as that they must pass. And so that will let you call a string of transactions. Like imagine if you did a 20-step arbitrage process where you want to switch this to this and this to this and this to this, it does have to all be on flow EVM, but it can be different contracts, different exchanges, different things, and it will run one at a time, and if the 20th transaction fails, it'll just rewind them all like it never happened and go back to the beginning state. So the way that this works in here is that we've provided some code in the background that just takes an array like this of transactions. This should all look pretty familiar. We've got the contract address, we've got the ABI, we've got the function name, we've got arguments for the function, and then we've got a second object in that. So these are those two transactions that we saw that the demo does automatically. We also have a code evaluator in here that I'm going to skip in the interest of time, but you can play around with some snippets and see how the tool responds to them. But we want to call our own contract. We want to do something different. So in this case, I've got a button clicker contract that I use for a couple of different things. It's a very simple contract where it just has a mint function and any wallet can call it, no permissions, no requirements. And if you call the mint2 function and give it an address, it mints one ERC20 token and grants it to that address. The idea being that you could use it for like a button clicker game, you know, a simple version of that. But one token at a time isn't a lot. We can cheat though. We can use this and we can call 10, or as I said earlier, maybe more. We'll find out. So we're gonna add a folder to our file. Let's actually move this around here so we can see both the instructions and the code at the same time. So we're going to go in source and add a folder called contracts. And in it, there's links to the button clicker repo in the tutorial. And we're just going to grab the hard hat ignition produced address file and move it over. And we're going to grab the artifact that has the ABI in it and stick that in as well. If you are using Forge or something different, then it'll be similar. You just need the contract address and ABI in an accessible way. All right, next we're going to add a hook. This is probably overkill, Cursor tells me, but I recently learned how to use hooks. I'm not very good at React. So we're going to do a hook, and I'm going to be proud of myself, and you're going to be proud of me too. So we're going to call useContracts.ts, and in it, again, we're not focused on React here, so you can just copy this snippet that is going to import these contracts and make them available throughout your React app. And the next thing we're going to do is we're going to add some traditional Wagmi components. So this is just the components for the button itself that you click and it calls the transaction to mint a token, and then the leaderboard that pulls and displays the top 10 list from the contract of who has the most tokens. So we're going to add in source, we're going to add a folder called components. And in that, the first thing that we're going to add is the button. And again, the tutorial provides this component for you, so I'll paste it in and go over it real quick. But it's pretty simple. Did I put my constants in a different place this time? Looks like I did. Constants contracts. Okay. So a little bit of cleanup we need to do here. I'm going to add a new folder in source called constants, and then put the contracts in there. And then why are we constants, contracts? Oh, why is it upset? I'm going to do some crowd debugging here if you have any ideas. Oh, you know what? It's because I changed it and I forgot to do this. I changed it to not be a hook. Sorry, bear with me. We'll edit this. Like I said, I am not a React specialist. I am working to become better at it. But what we'll do here is, oh no, because I'm confusing what I'm doing. Constants, contracts. No, why is it doing that? I turned off the robots because, okay, let's look at what we're doing. Oh, because I did that thing where I skipped a step. So we're gonna move our contracts folder back. And here we go. So we're going to go to we have hooks, we have used contract. What have I done to myself? Well, let's look at the reference. Wouldn't be live coding if something didn't go wrong. Classic demo. Okay, so we're gonna add the constants folder, and in that we're gonna put just a little file that exports our contracts so that they are easily usable. Oh, I dragged to the wrong place. I am used to a mouse. There we go. Constants. Oh, I can't. There we go. Okay, so this is going to create a button, and then the button is going to call handle click when you call it, and that is going to call a write contract function. Next up, we need a top 10 display that, as I mentioned, is going to show the top 10 scores. So if we go to components, add a new file called top 10 display.tsx. We'll paste that component in. So this one, it's a little bigger, but it's mostly just accepting in the list of top 10 scores from the read contract write, and then displaying that somewhat appropriately. It's not hugely styled or fancy or anything. And then if your score is not in the top 10, then it adds it at the bottom so you can see where you are. Finally, we're going to use a pattern that I like to do when I'm doing Wagmi and RainbowKit, which is a content component, which is usually where I handle all of the blockchain calls from. And that does two things for you. One is that it puts all of your blockchain state in one component in a base in a convenient place. And then the second thing that it does is, rather than having a new use write contract hook in each of your components that's writing contracts, if you put one in content and then pass that use write contract function into each of your components that are going to be calling functions, then you'll get the same state for transactions through all of your buttons. And so you can use that so that if you don't want people to be able to, click one button and then start a new, do a transaction and then start another transaction before that transaction is done, all of the buttons will be in the loading contract state or loading state in Wagmi, and you can use that to disable them, which I've found to be usually what I want to do and makes it more convenient. So we'll do content. We'll make sure we spell content correctly. All right, save that. See if anything is angry with me. So again, this is just the parent one. It's got the use effects for looking for the transaction receipt and then updating whether or not we're waiting for a response with that. Finally, we need to go back to our page, and that is an app right here. Where is that? There it is, page 2. And we'll go down to the content that's there right now. We're not using the code evaluator, so we'll get rid of it. And we'll add in content and tell it to import it for us. Then we can save this and check out the demo again. And now we can see we have our top 10 scores here. I am in second place. Someone has gotten ahead of me, that nefarious person. And if I click the click me button and approve, and I will stall the requisite amount of time for a blockchain transaction, and in a moment, it should update. Uh-oh. Missing or invalid parameters. All right, we can debug that one real quick. Components, the button. We need to delete that out. I was accommodating for a bug that no longer exists. Again, this is a brand new tutorial, so you're going to be just a hydration error. Yeah. Hydration error, we're not worried about that. This is not a React tutorial. This is not an Next.js tutorial. So we will ignore that. So now we can let that go through, and we now have 35 points. Do another one, stall for a little while, 36 points. But that's taken a really long time. So what if we want to get 10 points all at once? Well, we can do that with the new magic of Cross-EVM apps. So we'll go through, and we're just going to hatchet this in pretty roughly. So not really going to worry about best practice right now. But in the in page.tsx in the demo, we have EVM batch call, which is our magic array of batched EVM calls for transactions that we all want to do together. So just for the first pass at it, let's go through and get rid of the second one of these. And for address, instead of being the address of the old contract, we will do our constants. Let's see if it'll grab contracts for me. So we'll grab the import. We'll grab it from the button. We'll import our click token. Okay. And so our address is going to be clicktoken.address. ABI is clicktoken.abi. We can get rid of the other ABI. And our function name is mint2. And we already have our address here because we have COA, which again is our cadence-owned account. Does this need to be as ABI? And we'll import ABI from VM and COA.address. Okay, so we'll save that. This is only going to call it one time, but we'll just test and make sure that that's working correctly before we add more. Refresh this real quick. Send batch transaction example. Good, so we've got the transaction. We'll give it a second. We're not hooked into our refresh loop here, so we'll have to manually refresh once we see that the transaction has gone through. So here's the hash for it. We have 36 points, and we can refresh. Now we have 37 points.
What you did was you updated the UA address?
So great question. So EVM batch call is the list of EVM transactions that we're going to call in a batch. So previously, there were two existing transactions from the example, one to wrap a token and one to call the ERC20 approve function. And so we've simply used the existing array and deleted that and added our own call to our own function in a very similar pattern that you would in Wagmi or VM or pretty much any Web3 library on the front end to just give it the things that it needs, the address, the ABI, the function name, and the arguments. In this case, in our contract, we have a mint2 function that mints one token to whatever address is provided anytime that function is called. So now we could add another list here. We could copy and paste, or we could use some of the silly things that JavaScript lets you do, and we'll just multiply this array and turn it into 10 calls instead of one call. Again, in a real app, this is where you would be like collecting transactions when someone says, I want to put this NFT in my cart, I want to put this NFT in my cart, I want to put 50 of this token in my cart, or whatever is appropriate for the app. But here we're just using array from, which is some JavaScript trickery nonsense to make 10 of this item in the array instead of just one. So we'll go back to the app and we will refresh it. We'll send the batch transaction example, again, one approval, and now we need to wait for the 10 EVM signatures to show up, and it's passed. That was nice and quick too. We'll refresh it because we're not caught into our loop, and hey, look at that, we're tied. So I don't know what's going to happen here from this part. I haven't actually had the chance to test this, but let's see what happens when we do 20 transactions. Here we go, approve. I have no idea when this is going to break. I'm excited to find out. All right, here we go. Here's 20. We'll refresh it just so we can see our score. Let's do 40. This is going to get out of hand pretty quick. Maybe. Again, I have no idea what the limit is here. Do our batch transaction example. So now we're doing 40 EVM transactions with one signature. And here we go. All 40 went through. Got to refresh it. Have 170 points. Let it ride. 80 transactions. Send batch transaction example. Approve. I don't know when this is going to break. I'm getting excited. 80. There we go. Okay, so 80 transactions, somewhere between 40 transactions and 80 transactions is where our limit is for this, which I think is pretty good rather than having your user click yes, approve, yes, approve, yes, approve, yes, approve 40 times to buy 40 things on your platform or to do 40 interactions that could be done all at once. Logically, just can't be done all at once because of how the different contracts you're interacting with are structured. So that's it. That's all I've got. Thank you for your patience with the technical difficulties. This is the first time we're running through this one, so I'll make some updates to the tutorial.